Okay. Sorry. I don't even know. Okay, stay there. So, I don't like the way the book. I don't like the way the book introduces this stuff, but it's okay to look at it now that we talked about it. This should look familiar. What idea is this getting across? Well, you can read it, but I mean.
That radians are based on physical measurements.
Good. It's the literal radius laid down on the circle, and that's why they're better than degrees. Good job. And we actually figured this out the other day, that it was about this much. 1 radian was roughly this. This is how we convert. Yes?
Yes.
You don't even have to, I mean, these by themselves don't really necessarily make sense, but how would I convert 36 degrees to radians?
Multiply it by pi radians over.
Yeah, I want to kill degrees, so I put them on the bottom. I want to change it to radians, so I put that on top. And now you can just
Divide? Simplify?
yes, reduce. So like I could divide both by 18, for example. That's nice. And then I could devoid. Sure. I could be devoid of all feeling.
What accent is that?
Huh?
What accent is
I have no idea. I just misspoke and it became an accent.
It's Jeff's accent.
Yes, it's Jeffian. Hey. Oh my God, my memory's so bad. I have no idea.
that? Is it okay if she says
That's fine. I'm okay with emotional support humans.
Oh, yeah.
Okay.
I don't bite.
It's only if somebody comes in with like their kid, because they do use colorful language. I'm like, can you bring headphones for this? Is this okay, guys? We did this the other day. Why is this one easier? What do I do for this one to convert this to degrees?
You just plug in 180.
Yeah, because pi. I'm sorry, I'm shy. Because pi is 180 degrees. This kicks ass. This kicks ass is 1/2. Holy shit. Pi. I left the pi out. There we go. Wait, that can't be
Wait,
true.
it's not.
Wait, no.
Converting
10.
degrees.
Yeah, you have to multiply the two.
Yeah, I changed pi to 180.
Mm-hmm.
Why?
Yeah.
Okay, let me, because pi is 180.
Oh,
Pi is 3.14.
pi radian.
So right
In
now,
degrees.
this is in radians, correct?
Yeah.
All right, so pi radians
Is 180.
is 180 degrees.
Okay.
And so, let me see if I can slow this roll down. Oh, this is 10. There you go, Jeff. 50 degrees. Okay. Oh, I didn't say this, but first quadrant, so this is a weird choice. First quadrant, second quadrant, third quadrant, fourth quadrant.
Okay.
Right? Because when I cut this thing in 4 parts, I make these quadrants. And they kind of go the same way that we consider angles. This way is positive, this way is negative, so we count it this way. Is everybody with me?
Yeah.
Yeah, you'll never look at pizza the same way, I'm sorry. We talked about coterminal, yes? And how many coterminal angles exist for 45 degrees? Infinite. Now look at this. Okay, this is a good one. I love this. So now we're in what measurement are we in? Radians. So they put it there. Now real quick. If I go halfway, that's how many degrees? 180. How many radians is that? Pi, because we know 180 degrees is pi radians. Is everybody with me? 5 pi over 6 is not a full pi. Somebody has taken how much of the pi? 1/6 of the pi is gone, yes? So do you see why it makes sense that if I want to go 5 pi over 6, I don't quite go a full pi, I go short by a pi. And of course, we just figured out how much is this. What's this angle right here? We just figured it out. This is 5 pi over 6. How short of a full pi is that? Pi over 6.
I'm probably like losing the hell out of this. But like, why wouldn't the pi be the full thing?
Oh, why wouldn't pi be the full thing? All right. Do you remember what the circumference of a circle was? 2 pi r. So literally how many r's are there all the way around? 2 pi of them. And radian is the number of radiuses, right? So there's 2 pi all the way around. Now listen, I'm going to tell you this because I can't stop myself. There was a movement because we thought we shouldn't have the symbol pi mean 3.14. We should have the symbol pi should mean 6.28. So like the whole thing would be pi. There's been this movement for a while, and it's sort of like the people that, well, I agree with these people that want to make us use metric. I actually agree with that, but it's the same futility. It's never going to happen. But there are people that won't like that. But circumference is 2 pi r. It just is. So it makes sense to have the full thing be 2 pi, because that's the number of radiuses that fit around a whole circle. Yes? Okay. Are you guys all cool with this angle here is the rest that makes it a full pi? Because I stopped short of a full pi. How much did I stop short? Pi over 6. 1/6 of a pi short, right? If this is 5 pi over 6, this is pi over 6. I just added some stuff onto that problem, because, you know, that's what us math people do. So, can you find a positive coterminal angle? So for example, real quick, if I had 100 degrees and I want a coterminal angle, I could just add what to it? 360. What's 180 is pi, so what's 360 degrees in radians? 2 pi. Beautiful. Is everybody with me? So if degrees I add 360 or subtract to get a coterminal angle. In radians I add or subtract 2 pi. You with me? Does that make sense? It's the same idea, just different way to measure how far I'm turning. So if I want to, and this is where everybody's going to get really excited because fractions are going to become a big part of our life. If I take 5 pi over 6 and I add 2 pi, I get a coterminal angle, but how do I do that? No. You need a common denominator.
So you gotta multiply by 6.
Multiply by 6. 12 pi over 6 plus 5 pi. I'm sorry, 12 pi plus 5 pi over 6. Yes. You with me?
Yes.
And then if I want to do 5 pi over 6 minus 2 pi, because I can go forwards and backwards, right?
Same deal.
Same deal. 5 minus 12. There's, yes. Now real quick, negatives, now watch this. If I want to go negative, bless you. If I want to go negative pi, how will I actually do that? Pi is this. What's negative pi?
Either way.
Yes, this way, right? And don't stop to think about what that really is. When you take it out of the oven, what's going to happen to you? Negative pi. Sorry. Am I feeling okay? So if I want to go back, now look, I want this to make nothing, look, this is negative 7 pi over 6, yes? Do I want to go more or less than a pi backwards? More, how much more? 1/6 of a pi. So of course it's going to end up in the same place. I'm going to go pi, and then 1/6 more, back, yes? So just, you need to start getting used to moving around this in radians, which is kind of unfair, because you've been using degrees your whole life, and then I'm like, okay, couple days. Radians. Yes. I understand that feeling.
I'm trying to figure out how to.
Just start saying something and I'll pick up on it.
So 3.14 radians is half of the circle.
Okay, we'll go with that, roughly.
Right? Like pi radians is half of the circle.
Yeah, but please, everybody knows pi is not 3.14. Yes?
Well,
But yeah, I'm with you. That's what I mean. That's what I mean. I gotta be picky about it because there are people that think that pi is 3.14.
okay.
Even though if you write 3.14 and do a mirror image, it looks like the word pi, but we'll be okay.
So then the
Think about
entire circumference of the circle being 2 times.
6.28, blah, blah, blah.
Okay, so it's not a nice even whole number.
No.
Okay. That's it.
Okay. And it's all right. Yeah. Okay. I'll stop there.
That's it.
I could go off on this whole thing, but I'm not going to. Okay.
I was just trying to figure out how 3.14 twice added up to like 7 or something, and I was like, no, that's not possible.
No, it's because remember, the reason that these are actually, I know they're fractions, but they're still relatively nice, because we're not actually multiplying by the value of pi. That would suck. So we almost always do it as multiples of pi, so it's just easier to look at and mess with. I don't want to write freaking 48.73947. No. Okay. We talked about these two things. Length of an arc. S equals, I just write it as S equals arc theta. I'm crazy. And we talked about area, and again, they do it a different way than I did. But that's the area formula we got, yes?
Yeah.
Kick ass. Oh, do I want to mess with? All right. Let's talk about this for a real quick moment. So if you are on something that is rotating, it doesn't matter if you're right next to the center of it or if you're way out here, you're going the same angular speed. So you're sweeping through the same. So what's really trippy is if you look at the clock and you can watch how the minute hand moves. Yes, the minute hand moves quicker than the hour hand, but still pretty slow. But if you extend that out like 80 miles, then the tip of it, so if I do this, my arm is not moving very much, is it? But if my arm was suddenly thousands of miles long, the tip of my finger is moving really fast, linearly. Angularly, not an easy word to say, so I'm happy I did. It's going the same speed as any part of my arm, yes? Or else my arm would break and 1,000-mile long arm, I probably should expect that. Are you guys kind of with me?
So it's like watching the windmills?
Yeah. So the longer they are, the faster linearly the ends go.
When you say linear, you mean that like the ends are experiencing a faster speed than the
That
middle?
is technically the distance they traveled along an arc over time.
Oh.
We are currently going thousands of miles linearly.
Right.
Does it feel that way? And this is what gets people in the flat earth. Does it feel like we don't know it? In the flat earth. Sorry, it's just really dumb. They are out there. But of course, we are moving angularly. We are moving as quickly as the hour hand is moving. So
Versus
it's
like the
roughly
center of the earth.
15 degrees per hour is the rotation of the earth. Right? You guys know it? Huh?
Sorry, 15 degrees per hour, that's fast for something so big. Like,
How can it rotate?
So real quick.
Keep going.
I was gonna make a joke about it being flat.
It's like when you do the pizza. Whoa.
oh,
So
there's a
there-
pizza man?
Huh?
Sorry.
Yeah, there's no turtle underneath. There's a pizza dude. All right. Sorry. All right. Hold on. I lost. There was something I want to say related to what you just said.
Experiencing speed differently.
10 minutes, Scott. Okay. I'll be right.
Distance you're traveling over time.
Yeah. Something like that. Oh, the Earth rotates a full rotation, 360 degrees, in 24 hours, which is, did I do the math right? 15 degrees per hour, if I did that right. So if you do 360 divided by 24, I think it's 15. So 15 degrees per hour. 15 degrees is roughly that. Per hour, yes. Okay, yes, sir.
So is that where we get the time zones from?
I mean,
Was that
that's
part of it?
one reason why the time zones exist. The demarcation of the time zones is completely human-made. They could have been anywhere. And of course, you got places like Arizona. We voted to freaking give our legislature the power to stop daylight savings time, and they haven't done it yet. So it's like, I always thought we should just do half an hour once and forget about it. Just split the difference, right? Yes.
So if you like were to measure around like the outer part of the earth, like the higher atmosphere, like string and marker, that line would be a lot shorter than like the line that we make sitting here on Earth.
Oh, I see what you mean. Yeah, if you're right on the center line of the Earth, and of course it's tilted at like 23.5 degrees, If you're right on the center line, then you're obviously going a lot faster. If you're right at the North Pole, you're not going anywhere. Right at the, not the magnetic North Pole, but the physical North Pole, right?
The axis.
Yes, right on the axis, you're not going anywhere.
You just
Yeah, so if you're literally standing right in the middle, you're not going anywhere, right? Yeah, or you can think about if you're hugging like a pole, you're going, ah! But not really fast, because it's not moving. So, all right, I'm sorry. But that's a good point, yeah. So it depends on what latitude, longitude, what latitude you're at. Yes, always got to stop and think long and ladder. Okay.
So the angular speed is the distance, well.
It's just the angle you sweep in a certain amount of time. So if this little angle is swept out in a minute, yes, and let's say that's 12 degrees. That's 12 degrees per minute, correct? If I'm here and I sweep it out, that's still 12 degrees per minute. Now, if I'm here versus here, who went linearly further?
Your outside guy.
The outside guy, right? All right, so there must be a relationship between angular speed and linear speed. And of course, if you look halfway down the page, you can see it. But why does that make sense? Because what's this distance? Why did I go further? Because what's this? What do we call this? What is this? Arc length. Kick ass, and that's S, right? Of course it's S. That only makes sense because there's no S in the word arc length at all. So let's use S. And what was the formula for that? Sorry.
Beta times
R theta, 11. R theta. So watch this. If I multiply, screw this green box. Don't worry about it. If I multiply both sides, oh, by the way, I'm sorry. By the way, stay with me now. Stay with me. Linear speed is like miles per hour, correct? It's like distance traveled divided by time. Angular speed is degrees or radians per hour. What angle you swept out divided by how long it took. You with me? So it's kind of built the same way. One is how far did you move linearly, and a line doesn't have to be straight, by the way. So I can walk along a curve, but I'm still moving linearly. I don't know if you guys are with me or not. Math people are weird. We have curved lines. So just deal with it. Angular is more about how much it sweeps out. And that's why it doesn't matter where on my arm I am, I'm going the same angular speed. But this has gone much further than this has as I move, yes? Y'all agree? Yes, cool. Okay. If I take, and by the way, this is the letter, does anyone know what letter this is? Good try. It's a Greek letter. It looks like a W. I don't blame you. Omega. Kick ass. I am the alpha. No. So this is the Greek letter.
You said it's a Greek letter. I said I know it.
So we call angular speed omega.
Yeah, the letter for velocity is V because we're very creative, and the letter for angular speed, of course, is omega.
Is that the variable that's commonly used, or is that the unit?
No, that's the variable.
Okay.
Like H for height, V for velocity, omega for angular speed.
So is V velocity here too?
Yes, V is velocity. So I'm getting there. Hold on.
Oh, so sorry.
If I take omega and I multiply both sides by R, what did I just make the top become?
Your arc length.
Arc length. So arc length divided by time would be linear speed, would be velocity, and that's why this happens down here. V is R theta over T is R omega. Let me stop for a minute.
So
What? Good.
Sorry, the radius times the angular speed is equal to the arc
The
length
velocity.
divided by time.
Do it again. Sorry.
The
Yeah. Yes.
Radius times the angular speed
Is the arc length divided by time, because the angle divided by time is the angular speed.
Okay. Yep.
Angular speed should be how much angle changes over time. So it's theta over t. And that's what omega
And
is.
the arc
Yeah.
length.
And r theta is s. Is arc length, yeah.
Wouldn't it just be? I mean, theta is the angle, right?
Yeah.
Why?
Theta is the angle.
So why do you need the
So if I want angular speed, it's theta divided by time. If I want to know how far something actually moved, that's velocity, which is r omega,
Okay.
which is arc length divided by time. How far it actually went.
Oh.
Yeah.
Theta is the degrees over all of the parts, not just
Theta is the
the
degrees, sure.
over all, like.
Yeah, how much
no
it
matter how
sweeps
small,
out
yeah.
versus how much something actually moved.
Yeah,
So if I'm
the
here,
actual
my
distance.
r is much smaller than if I'm here. Yes?
Yeah.
Where's my center? My elbow. You guys with me?
But
So if I'm here, my r is much smaller than if I'm out here.
it's the same degree.
You guys with me? All right, let me draw it. 'Cause,
Is something like seconds in the watch? If it goes
Yes.
something like this,
yeah, yeah.
how many degrees?
Oh man, I'm sorry I announced that on. What's up?
So we were talking about angles, so watch seconds, thing about 20 seconds.
Yeah.
So if it goes something till 3, is that 90 degrees? So
I mean, sure. Anything circular you can break up into
Yeah.
degrees. Sure.
And this is measured by V, like the distance.
The distance the tip goes, you could say is measured.
Yes.
The distance anything goes, but yeah, this would be the radius. So if this turns, the distance it's actually traveled is V equals r omega. Yes.
Okay.
Okay.
And you get speed.
Real quick, guys, what is omega for the second hand? How many degrees per minute?
60.
All right, let me stop. Every minute, how far does the second hand go?
360.
It goes all the way around, which is 360 per minute, correct?
Yeah.
So for the second hand on the clock, omega would be 360 degrees per minute. Is that cool? That's a real concrete example of omega. Now, how can I write this better, using better than this stupid thing?
2 pi.
Radians would be what for
2 pi
360?
r.
2 pi per minute. 2 pi radians per minute. Not 2 pi r because
Oh, yeah.
r is radians. Like the r is the number of radiuses. Yes. Okay. Is everybody with me? You guys with me? So let's say, oh, where did I lose you?
No, I'm processing all the new symbols and words.
Understood. If that second hand, from the center, I'm not going to count the part that goes back. You guys with me? From the center out, that looks to be maybe 5 inches. Maybe? You guys with me? From the center out, which says roughly 5 inches. So how quickly is the end of that going? Yes? That's the question now. This is how quickly it sweeps out angles. Now I want to know how fast is it actually moving. So if I take 5 inches, because it's 5 inches away from the center, that's the radius, times this, I can get how fast it's actually moving. And this was 5 inches, yes?
Yes.
Okay. Now here's one thing I need you to understand. Radians is literally number of radiuses. Yes? All right, I'm going to say this 2 different ways. The way I looked at radians when I was a student is they're not really there. If I multiply by inches, my units become inches. The more correct way to look at it is what was 5 inches? What did we just say 5 inches was? The radius. So this is 5 inches per radius, so these just cancel. So whenever you multiply something that's in radians by something that has a unit to it, the radians go away. And that's really why, because then it's like that per radius. Okay, maybe. Yes?
I feel like I'm always trash cans.
No, go ahead.
So, anyway, what? Why does multiplying the angular speed by the radius give you give you the linear?
Okay, real quick.
How does that work?
If I walk in a circular path,
Sure.
and let's say I go 10 feet in 3 seconds, let's say 2 seconds.
Okay.
10 feet in 2 seconds. How quickly did I just move? agree with me. So if I walk the length of an arc, 10 feet in 2 seconds, I went 5 feet per second, yes? So if I could find the length of the arc divided by time, you agree with me that would be how quickly, the v, that's the velocity, correct? And what's arc length? What's the formula for it?
Well, I guess I'm just getting confused, cause like, isn't velocity like, I thought that speed was distance over time, not velocity. Isn't
All right.
velocity a different,
I'm
or am I
sorry.
like physics brainy?
A little bit.
Okay.
Velocity involves direction, and speed doesn't.
Right.
I think, now I'm trying to turn my own physics brain off because
Sorry.
they use linear velocity here, yes?
Yeah.
They say speed here, actually, yes. So technically it should be this, but that gets confusing because people don't realize that's not just absolute value, it's actually length of the vector. There's a lot of shit on the side of this, okay? So they use the letter V, which is velocity. So I'm gonna say velocity.
Okay.
If I saw absolute value V, that actually means speed. I'm not gonna be able to stop myself.
Okay.
They really mean speed.
Okay.
But we're not gonna use the letter S for speed because S
Why would
is
you do
arc length,
Right.
Yeah,
right? Of
Yep.
course.
clearly.
Clear.
Oh.
You don't use an S just because it starts with the letter S. That'd be insane.
No, we gotta use the French version.
Yeah, whatever the French version
Gotta have
is.
some great reason.
Is everybody okay?
Okay, so
Since when you multiply R, you end up with R theta over T, and you just agree the arc length divided by time would be the speed. And if it was velocity versus speed, you're fine. They really should be speed.
okay.
When I see V though, I think velocity because that's what it means.
That's all right.
So okay, so the distance that you walk is the distance of it, which is theta.
No. Okay. When I walk this circle, theta is the angle. So if I'm walking this circular arc, everybody agrees there's a center somewhere.
Okay,
You with me?
sure.
Even if I don't make a whole circle, there's a center to this little piece of the circle I'm walking. The angle is how much angle I'm sweeping out.
That's theta.
Yeah, so help me out. Fatima, can you stand right there? Are you willing? Are you okay?
Yeah.
You're not gonna have to do anything except stand there and turn a little bit. Now, watch. Okay, Fatima's at the center of my circle, yes? So now, I want you just to, can you rotate with me as I move? Can you like keep me, you understand what I'm saying?
Yeah.
You with me? So move your whole body as you follow me, ready?
Okay.
Okay, here we go. Okay, now, she moved a certain angle. That's the theta.
Okay.
The distance I went is related to the speed.
Okay.
So I have how quickly she rotates is the angular speed. And see how it doesn't matter how far away from her. If I get further away and then curve my arc and move, she's still going to move at the same speed. Yes?
Yes.
Okay. Does that make more sense? So the angular speed is how much I'm sweeping out.
Yes.
Has no bearing on how far away I am.
And that is the distance, which is the angle you went times the radius. Yes.
The length divided by the
time.
time. So length divided by time is speed.
Right.
Yes. Okay.
Okay, so that part I get, and that is represented by the W guy, omega. Yes?
Well, no, omega
wait,
is
wait.
theta divided by time. Omega is just how quickly the angle is changing.
The speed is V.
Right, okay, linear speed is what we just did, which is,
So real quick, if you watch a plane going over here, and you go, look at the plane. That angle is changing very slowly, yes?
Yeah.
You agree with me? So like right here, that's like the 0, and then I'm watching the plane move. That angle is moving really slow, yes?
Okay.
That plane is so freaking far away though, that the arc length at the end of that is huge. And we all know the plane's going flipping fast as shit, yes? You guys with me?
yeah.
So, to be honest, when I said something a little wrong, if I got further from you, if I wanted you to turn the same speed, I'd have to go much faster because I'm so much further away. And you all know this, you see something really far away, it's going really fast, but to you it's like, but the further away it is, you're like, holy shit, that thing's going fast. Yes?
Yeah.
Maybe? Sort of?
Okay, so
All right.
let me repeat back, just see if I.
Alright.
So theta is the
Angle.
angle,
Mhm.
okay? Theta divided by the amount of angle divided by time is how fast the angle
It's
is
changing.
changing.
So that's the angular speed.
Angular speed is how fast the angle is changing. Okay, take the distance at the end that it went.
You create the distance by multiplying by r. If I take angular speed and multiply by r, it becomes the distance I'm actually traveling if I'm that far away. So I could actually, I don't know, you feel like getting up again? Can you be my center again? Okay. So, all right, what I want you to do, if you feel comfortable, can you look this way a little bit? Okay, what I want you to do is start rotating slowly. This way.
This way.
Okay, no, wait, come back in. Just go really slow. Okay, go. All right, so if I want to stay in our eye line, I got, now, come back to there.
Okay.
Now rotate the same speed.
The same.
Yep. No, so the further I get away from her, the faster I have to go to keep in her eye line, because my R has gotten a lot bigger. I don't know if that helps.
It did.
Good.
That's why you
Thank
have
God.
to
Okay.
multiply by the r.
Yes.
Because
The distance I am away from the center of rotation, the faster I'm going to go given a certain angular speed.
Right.
And that was you turning slowly. So if I'm like right in front of you, you start to turn slowly, I just got to go, And if I get really far away from you, you start to turn, I've got to go, Wah! Yes?
So the angle divided by time is represented by omega,
Yes.
which is how fast the angle's changing.
How fast the angle's changing.
You multiply it by how long the radius is,
Yes.
it gives you how fast your end is going.
The linear speed at the end of that.
Yes.
Yes, okay.
Alright. I'm
Alright.
sorry if y'all got that already.
No. Everybody else is like,
Sitting
well-
here having visions of everyone going, Jesus.
no, you're fine. Okay, you're fine. The only thing I've noticed is if I explain too much, sometimes students go, well, I thought I understood it. I'm like, damn it. But we'll see. Nobody said that yet.
And they call it velocity, but it's really speed.
And they call it puppy love. No, they do call it speed, but they just use this.
Okay.
Yeah,
I hate that.
and you're fine. So I have to be careful when I talk
Here
about
it
it.
says it is the measurement of speed in a certain direction of motion.
Yeah, like right here, linear speed. They say speed,
Yeah.
but I wrote that in. That would be speed. Okay. All right. I'm not going to suddenly throw vectors at you, but has anyone ever worked with vectors before?
Yeah. Briefly.
So like a vector, if I could pull up a wind map, and the smaller the arrow is, the less force the wind is, the less the velocity of the wind, and the bigger, the more gusty, the more strong the wind is. So when I put that little absolute value symbol on it, that actually literally means length of the vector. So velocity is just speed with direction. Oh, that's something else. It's more than we have to worry about. I don't care about this part. Okay, so let's get to the exciting part. So, what I want you guys to do, this is where I'm going to break you up into groups. We're going to do a reverse little. Oh, it's amazing. Alright, for the people who are at home. Okay. And we're caught. Damn it.
So, sorry, just to repeat what you just said with the
Yeah.
calculator thing. The sine to the -1 means it's the inverse, not the
Yes.
reciprocal.
So this is inverse.
Okay.
So if you want to calculate cosecant of some angle, let's just say cosecant of pi over 3. In your calculator, you have to do 1 divided by sine pi over 3.
Oh, so 1 over sine. Okay.
So if you wanted to have a button that would do that, they would have raised the cost to $200 and something dollars. I'm making that shit up. So now we got all 6 trig functions to go with all 6 ratios, yes?
Mm-hmm.
Okay. All right, I'm doing good. Let me see. We're having a good time. Let me ask you this. Yeah, let me do one little thing that'll get you ready for one thing. Two things. Old Greek dude. If I ever say old Greek dude, what I mean is how would you figure out the last side of this triangle? Now, what I have to tell you first, though. Right? And we all know that symbol means it's a right triangle. This only works for a right triangle. And real quick, do you guys know the Pythagorean theorem? Alicia's looking at me just the way you should. She's like, The Pythagorean theorem.
Yes.
That Pythagoras took credit for and his followers actually found. He was the cult leader. Math history's funky. Pythagoras was a cult leader, his followers did most of his work. And then he took credit for it, yes. I know. And they didn't have Kool-Aid yet, so they couldn't get them to do that. Kool-Aid. Let's try it.
What you would really like, there's a book called Cultish that you would really like. It's about the language of cults.
That sounds very familiar. How do I find C?
A squared plus B squared.
Yeah, so C squared would equal. Yeah. Now, real quick, have you ever seen this? I got to show you this at least once. I'm sorry, Maria. There's a lot of sitting around for you today. I'm sorry. If I, what will I do? I'll get paid. If I build squares off of the sides, what's the area of that square? Pretend like it's a square. A squared. What's the area of this square?
C squared.
B squared. What's the area of this square? C squared. The area of this plus the area of that is the area of that. So there's a really cool thing somebody built that it's these, I get to say my favorite word. Fill these with water, and if you rotate it, these flow and fill this one perfectly. So it's a neat visual. There are 53 proofs of the Pythagorean theorem that I've actually seen and worked through. This is my favorite. It's not a proof, but it's a neat visual just to remember. Oh, that's why it's squares. That's why it's squares. I'm not just going to add A and B and get C. It's got to be squares. Okay. So up here I would get the square root of 9 plus 36, 45. Now here's where we're going to have a lot of fun. Can you simplify this? Break it up. What goes into 45 you can do the root of? 9. So this will be 3 rad 5. So you do the thing you can, you leave the thing you can't. Life lesson. Right? To meet the serenity. Okay. Yes.
You keep showing us stuff that seems to prove whatever it is you're telling us, and then you say, well, it's not a proof.
This isn't a proof.
Yeah, so what makes something a proof?
The I set up the conditions and show how it logically leads. This, I didn't show how it logically leads to shit. Right? I need you to see this. This is kind of neat to see, and it will help you remember why they're squares, is my hope.
Yeah.
I'm not going to go through a proof, because right now we're not going to get much out of it. And to be honest, over half the proofs requires to know some trick. Well, there are a lot of proofs we could do that wouldn't require us to know trick.
Well, I mean, like, when you were showing us, like, the logarithmic,
Yeah, I showed you one time. I showed you the full course of it.
Like,
Yes.
for some of them, you took us through the math about why it worked, like the properties of
Derivation?
logarithms.
Sure.
Yeah.
Yes.
But then you said, well, this isn't a proof, but it did.
Oh yeah. I did one proof. The log of A times B. I actually did the proof. And then the rest of them built kind of like off that or side to that. Or if this is multiplication becomes addition, then division becomes subtraction. But I didn't prove those. Okay. So, what was I about to do now? Oh yeah, that's one thing we need to know. Pythagorean theorem. So we all know that. One other thing, what was it, Jeff? Do you remember? Sure. If I tell you that, let me see if you guys are cool with this. If I tell you that the cotangent of an angle is 4/9, yes? And I'm going to draw the triangle. Perfect. So Braden noticed something right away. This is the one thing SOHCAHTOA doesn't need. So you either do this, you ready? Watch me. Watch me. You do this. Or you do this. Yes? I mean, ooh, then I don't need SOHCAHTOA. SOHCAHTOA sucks. Okay. Now, real quick. Cotangent theta is 4/9. Every trig function is the ratio of sides. This means I know at least what the sides reduce to. So which side is related to 4? And now if I move it like this and I put my angle in the base, cotangent is x over y, so this is x, this is y, yes? And then if I needed to, I could find the hypotenuse too, right? So if I just tell you trig function equals fraction, you can label the sides based on which sides that trig function relates to. Let's see if you can, because we're going to do this. Bum, 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 bum. Kelvin needs one, Maria. Oh yeah, I need one too. All right, guys. So what I want you to do. Let me see. Let's start off alone. Start off alone and afraid. So try to do this yourselves, and then we'll get into groups and check with each other. So what?
Did you say suck a toe?
I thought that's what they said. All right. All right, guys. So if I finish this out, everybody got 12? So there's certain triangles, 3, 4, 5 is one of them. 5, 12, 13, 7, 24, 25, and that was one of your groups up there. Most of the time, though, I'm always going to have a radical on at least one side because they're related with squares through the Pythagorean theorem. Are you guys with me? But there are certain numbers, and believe me, there's a whole history of studying these numbers and trying to figure out how many there are, how many triplets there are. They're called Euclidean triplets or Pythagorean triplets, but Euclid did too many things. Didn't leave enough for everybody else. Now, the main thing that I cannot do as good as SOHCAHTOA, the only thing, let me say, because main makes it sound like it's more, but this is it, is I have to do this and go, oh, that's why. Does everybody understand? This is why, because it's the y-axis, yes?
Yeah.
If I put the angle in the base, y-axis, x-axis.
Wherever the right angle is like the center of the circle.
Yes.
Washing machine.
Well, not really. This is actually the center of the circle here. So you gotta be
Well,
careful.
I mean, for purposes of.
Oh, I see. Okay. So then sine is going to be y over r. Make that r. So that'll be 5/13. Cosecant is easy, and once I get sine, I just turn it over. Cosine, you got what? 12 over 13. So then secant. Now, real quick, I want to address something. Do you guys see how the cos shit doesn't seem to really be in the right place?
Yeah.
So let's finish this out, and then I'll talk about what's. Tangent would be 5/12, and cotangent would be. That's crazy. So this is the only one that seems to currently make sense. Do you agree? I still remember thinking that way. Sure, Jeff. Once you get to calculus, you'll definitely see why the co stuff is the co stuff. You'll start to see there's deeper reasoning behind our naming. Right now, it don't make a damn bit of sense. Here's sine and cosine, and here's secant and and then here's tangent and cosine. These are the only ones that seem to go together. To remember these, I always think S goes to C, C goes to S. I don't know. If you come up with something better, tell me. Somebody's giving me this look like, I'm trying. I'm sorry. If you come up with something better, I'll steal it, teacher from now on, okay? And I'll name it after you. What'd you guys get for this side? Thanks for all the help. Thanks for all the help. I did see several of you get square root of 41, so I'm assuming everybody might have. And now the angles of the base, which kicks ass. So then sine is this. Now, real quick, I don't know if you guys remember this. Do you know what you have to do there? Here. There's something wrong with this. All right, radicals suck already, so dividing by them sucks even more. So in general, what we do is we call this rationalizing the denominator. We multiply top and bottom by the bottom, and that makes the bottom rational, not irrational. This is something you're gonna have to get used to.
What?
I just got the number.
Yeah, don't get the decimals. Is that what you mean?
Oh.
Yeah, don't go to the decimals. No. No.
We just have to know.
Do we have to do that? Or is
Yes.
this okay.
Yes, this is a must. This is not an option.
Only when it's in radical form.
It's not technically incorrect.
I know, but we prefer
We
a
gave that.
number of radicals. So like this is 541st square root of 41. This
Is,
doesn't really make much sense.
Okay.
Yeah. Now, in the grand scheme of things, this don't mean shit. But that don't matter, because right now we're dealing with the immediate scheme of things, and this is important.
okay.
So what's cosine?
4 to the square root of 41.
So that becomes 4 rad 41 over 41.
Mm-hmm.
Whatever you say, Jeff. Tangent,
5/4.
5/4. Do you notice that tangent is sine divided by cosine?
Mm-hmm.
Because the bottoms would cancel if I divided them. So that is actually a thing worth noting. That is a identity. So what's cotangent? No. Oh, I like it. Yeah. But cotangent is cosine over sine. But you could also build off a secant and cosine. What's cotangent? Over here, sorry. I mean, specifically. 4/5. Now watch this. What's secant? Don't do this shit. What's secant? Turn this on over. Yes? You guys see that?
Grad 41 over 4.
Because then I don't have to rationalize it, yeah?
Yeah.
And then what's cosecant?
Grad 41 over 5.
Okay, I like it. So, is that alright? So if you didn't write it that way, do it forever now. Thank you. Much appreciated. This is kind of cool. We don't currently have a way to solve this. Now, real quick, you notice this. So if you look above your tangent button, don't you see an inverse button?
Mm-hmm.
Okay, now go with me. We're going to do this 2 ways. Do you see tangent inverse? Okay. So you guys be ready. But I don't need that. I don't need its help. But I want to show you how we get the same answer. Tangent's 2/7. So if I put the theta in the base, where's 2 go?
On the left side.
On the side.
Do you see that tree over there? Alright, I'm with you. I saw you. You're going this side. Yeah, you're fine. And then where's 7 go?
The base.
The base. And so you get here, because for cosine I need to know this one, so that's going to be
Square root of 65.
53.
53, yeah. So it'll be 49 plus 4. You're good. I like how you said that with, like, you're like, yes, you scored a 60.
Yeah.
I'm not sure what
That's
happened
good.
though.
You
What?
set me up. That's
Oh,
what he
man.
told me.
He's totally
I didn't even
set
try
you
solving it.
up. Oh, shit. Okay, so then what's cosine theta?
Hey.
Okay, yeah. So 7 over square root of 53, which is 7 square root of 53 over 53. Now somebody do me a favor. What is 7 divided by the square root of 53? Just give me a rough. 7 divided by the square root of 53.
1-ish. 1 plus
0.9615
Yeah.
23947.
Okay. I might, oh shit, this might be beyond this a little bit. Here, you guys can handle this. If you have a TI calculator, can you hit mode real quick? That little button right there, mode.
Mm-hmm.
Look at all these options. For the most part, you want everything to the left highlighted until it says fraction type. You want all this. If you have any of this over here highlighted, it could lead to freaky looking results.
What about the
Huh? The what?
A plus BI?
A plus BI. Where's it? Oh, there it is.
I like that
Oh, sure. Then it gives you like complex solutions, yeah. Do you see right here radians, degrees?
Yeah.
That seems very important.
Yeah.
It does.
Okay, so make sure it says radians for you. Make sure radians is highlighted. Now, real quick, let me see. Just because this came up, tangent theta is 2/7, yes? Let me see if you guys are cool with this. Tangent theta is 2/7. All right, let me see. I really want you guys to be so cool with this. How would you solve cube root of x is 2? What would you do? What would you do to both sides?
Raise them to the third power.
Third power, why?
Because it cancels out.
Because these are inverses of each other, so they kill each other, yes?
Mm-hmm.
X equals 8. So what would I do to both sides of this? I would do the inverse tangent. for the same stupid reason, yes? Just because it's a new function doesn't mean it suddenly gets to work different ways than other functions. It's just another function. These kill each other. You with me? So I can figure out what the angle is in radians. So let's see. Inverse tangent. So second tangent gives me inverse tangent of, what was it? 2 divided by 7. I get this angle.
Yes.
That looks suspiciously close to E.
Oh, sort of. Not really. Okay. Okay. Then if I take the cosine of that, let me show you cool. I don't know if I've shown you this yet. Everybody hit your cosine button. See ma? And then if you do second negative, that little ANS, that's the last number that was on the screen. So I don't have to type this whole stupid thing over again. I could do cosine of that angle. And I get the same thing we got earlier, yes?
Yeah.
But I hope you guys understand, I prefer this way. But obviously that's not a great place to use inverse trig, but there are really good places to use them. Okay, enough of that. So how do I do this? I think I got around to almost everybody. Oops, I don't want to. This leads to this, and then x squared plus y squared equals r squared. Oh good. And then this is 1. So then we know that's an identity. That is a known fact. Sine squared plus cosine squared equals 1. That is just a thing we know. You're going to have to know a lot of those things. We are going to create a list of trig identities. And it's going to be your favorite thing ever. How much time we got? Not much. Last thing, what's an equilateral triangle?
It's a triangle where all the angles are equal.
Angles and sides. So all the sides are the same. So I'm going to call them x, right? You didn't have to call them anything. And all the angles are how big?
60 degrees.
Yeah, because if you evenly split 180 across the 3, you get 60. If you draw in the height, what kind of triangles you made 2 of just now?
2 right triangles.
2 right triangles. How big is this angle here? 30 degrees. Now, if you'll just give me a moment. How long, if I just take this right triangle and draw it again, how long is this side? It's not x. How long is this side? Chop. X over 2, yes? Okay, go with me. This side is still x, yes? If I wanted to know, have you ever seen the right? Damn it. If I want to know what sine of 60 degrees is, what am I missing?
Your y side.
My y side. So how do I get the y side?
Y squared plus.
Yes, everybody's super excited because there's not a lot of numbers. Y squared plus
X over 2 squared.
x over 2 squared equals
X squared.
x squared. Just watch for a bit, I'm sorry. You're like, if we could see it, it'd be easier. Y squared plus x squared over 4 equals x squared. If I subtract 1/4 x squared from a full x squared, I get 3/4 of an x squared. Is that cool?
Sure.
And now I'm right now trying to figure out why I can never give myself enough space. So then y would equal, if I take a square root and remind myself that y is part of a physical triangle, can't be negative, I'll get square root of x squared is x, yes? Square root of 3 I don't know, square root of 4 is 2. So what is the sine of 60 degrees then?
X.
It's y over r, yes? So it's x rad 3 over 2 over x. The x's cancel. Sine of 60 is rad 3 over 2.
Wait, they can cancel through multiple divisions? Oh, I guess because division is, yep.
Well, I have x of these divided by x is 1. Yeah. Is that okay?
Sure.
Do you guys, some of you guys have seen trig before. Do you remember sine 60 degrees is rad 3 over 2?
Yeah.
That's why. That's physically why. Yes? Yeah, so if I do cosine of 60, that one's nice. What's cosine of 60? What's cosine?
X over R.
X over r, so it'll be x over 2 divided by x, and now we can do the trick we just learned. So cosine of 60 is 1/2. Now real quick, why does this make sense? 60 degrees, what's it closer to, the x-axis or the y-axis? 60 degrees. Closer to the x or the y?
X.
is closer to the y, correct? Because how far from the y is it? 30 degrees. You with me? Because that's 90. You with me? So which should be bigger, sine or cosine? Which one likes y? Which one goes like
Sine.
y? Sine. And which one is bigger? Sine. That's rad 3 over 2, which is definitely bigger than freaking 1/2. Yes?
How is that 1/2 x over 2 over x?
All right, real quick. You ready? If you write x over 2 divided by x, that's x over 2 times 1 over x, the x's cancel. Or even better, just 3/2 divided by 3 is 1/2. 3 anythings divided by 3 is one thing. Okay? So x halves divided by x is 1. Okay. All right, we did a lot today. It all comes together. I need you to see this. Students feel like there's a lot, but everything comes from each other. It's all, so that's why I keep talking about stuff we're not supposed to talk about yet, because it's there. It just comes out. That's definitely enough. So if you guys have questions, you can hang out after. Otherwise, I will see y'all next week. I want to have that standalone quiz on 6.6 and 6.7. So that's the, it's out of my head now. It's gone.
Wait, what? A quiz?
What is it? Oh, solving exponential equations and logarithmic equations. And then like beautiful word problems.
Wait, when's the quiz? All day?
I haven't said yet.
Oh.
So we can either have it, well, let's see. Let's do the quiz on Tuesday.
Okay.
So I'll give you a day on Monday for questions if you haven't had a chance to do the homework yet. So we'll do, the next quiz will be Tuesday on section 6667.
Oh, they can't see the paper? I think just a picture of it.
Have a good weekend.
Yeah.
Got a meeting after this.
Really? That sucks. I'm sorry.